Hi everyone, good morning and welcome back to my channel. Welcome back to my tech talk. It's been a while. So in my third week of blockchain development, I'll be talking about Solidity. In case you are just joining us for the first time, this is my third video, and I would like to introduce myself once more. I'm Patrick Ominisa. I'm a blockchain development student at Web3Bridge Lagos, Nigeria. So thank you for coming, and I hope to make this session wonderful. I hope to make it interesting for you. So we'll dive into the basics of Solidity, and towards the end of the video, we are going to write a smart contract, a deposit contract. Don't worry about that. I'm just about to explain what we have for this week, for this session. Remember, we are talking about Solidity this week. So, what is Solidity? What is Solidity? Solidity is an object-oriented programming language influenced by JavaScript, C++, and Python. Solidity is not too different from these languages because we apply the principles of these programming languages I just mentioned inside Solidity. Most especially JavaScript. You are going to apply JavaScript a lot, and then there is also TypeScript. You are going to apply all that in Solidity. If you can know these things, it will be very easy to write in Solidity. So what do I mean by the statement Solidity is an object-oriented programming language? You see, object-oriented, it means everything you write, be it an integer, be it an unsigned integer, be it a string, a word, or whatever, you have to define that data type. You have to define the data types. For example, in JavaScript, you can just say A equals to 5. You can say B equals to 7. You can say C equals to 10. In Solidity, you don't have to do it like that. Like I said, we apply the principles of these programming languages in Solidity. But what makes the difference is that in Solidity, you have to define your data type. You can't just say A equals to 5 in Solidity. You have to say unsigned integer equals to 5 or integer equals to 5, because an unsigned integer is any number from 0 and above, and then an integer is any positive or negative number. So A equals to 5. 5 is an unsigned integer. So you can just say unsigned integer equals to 5 because that's the category it falls into. It is a positive number. So that's for data type unsigned integer. And then, for example, you want to say word equals to let me use like my name for example. Let me say Patrick. Word equals to Patrick. Or let me say word equals to Web3Bridge. It's a word, it's a statement. Because a word or a statement is a string, you have to define that data type as you are writing it. So you have to say something like string word equals to that string that you are putting before the word. You are defining the data type. So string word equals to Web3Bridge. And then Solidity takes into consideration your symbols or your punctuation. You have to put in a place where you have to put a comma, you have to put that comma. In a place where you have to put a semicolon, you have to put it. So that's for the data types. And then I defined Solidity as a programming language. And then I define Solidity as an object-oriented programming language that uses the principles of JavaScript, TypeScript, C++, and Python. You see, Solidity is not really the language that is being read by the Ethereum virtual machine, where smart contracts are being run. Remember, you write your smart contracts in Solidity. That is, Solidity is the programming language that we use to write smart contracts on the Ethereum blockchain. So, when you write in Solidity, there's actually something happening to the Solidity code. You don't just write Solidity code and expect it to run just like that on the Ethereum virtual machine. So what exactly happens to your Solidity code when you write it, when you deploy on the Ethereum blockchain? You see, Solidity is actually being converted into what we call bytecode. Your Solidity code is compiled and then converted into bytecode that is readable by the Ethereum virtual machine. What am I trying to say? What I'm trying to say is that Solidity is human readable code. The Ethereum virtual machine can't actually read Solidity. So what happens is that our Solidity codes are being converted into the bytecode that the Ethereum virtual machine can read. So where will your Solidity code be compiled into bytecode? Where will your Solidity code be converted into bytecode? There are a lot of softwares out there. For example, from the Ethereum website, we have Remix. Remix IDE is an integrated development environment where you can write Solidity codes, compile them, and run them. It shows us exactly how smart contracts, how Solidity codes are being run on the Ethereum virtual machine. And then there's also another one which is called Hadat. Yeah, we wouldn't really be talking about Hadat at the moment because we will talk more about Hadat in our fourth and fifth week. So in Hadat, you do basically same thing with same thing with the Remix IDE. It's just that in the Hadat environment, we write scripts to run our codes. We are going to write a smart contract, and then it's going to be compiled there in the Hadat environment, and then it would be run by a script. So those are softwares that we can use to run our Solidity codes. The basics of Solidity, they are just like your normal JavaScript code, So I will be explaining so many of them, though I know I can't explain everything, but my aim is that you understand what I'm trying to explain to you. So with the aid of the screen recording, I should be able to do that.
For this section of our video, I will be screen recording to enable me to explain better what we've been learning so far. Yeah, the basics of solidity, that's what we are going to deal with in this part. Yeah, so we are going to start with there are so many, I wouldn't be able to explain everything. I will just mention some of them and explain like one of them, and then towards the end of this section I will explain the smart contracts where we are going to apply some of these basics. So the basics of smart contracts. First, we have the data types, where we have the okay, let me click on that. That's a smart contract that built into show data types. As you can see here, we have the assigned integer, assigned integer 8, string, bytes 32, boolean, and address. So this is also like these are data types, and there are actually more to this. And then we also have the functions. Yeah, and then we have the functions that we can use to write to our variables. Yeah, and then we have the view functions as well. For the write functions, we can take in parameters. For the view functions, we use them to view our codes. Then, for example, like we use them to view the output of different codes. And then we have here this is a simple string code where we say string public migrating equals to Google error. Yeah. So there's something I want to explain here. In Solidity, we have to define our license, which is a comment line, and then we have to specify the Solidity version as well. Here, Pragma Solidity 0.8.1 is the symbol here, which is indicating that the Solidity version is our smart contract we are written here is compatible with here is the Solidity version greater than 0.8.1. Then we have others as well. We have the modifiers, we have constructors. This is how the modifier is written. We have the constructors, we have the require, we have interface and imports, we have random numbers, arrays, and delete and pop in arrays. These are the basics, and then your for loop and while loop that we do in JavaScript and other programming languages. We do all that here in Solidity as well. Almost same syntax. Like look at this here, for loop. There's not much difference, just some few things added to a normal JavaScript code. And then we have the structs, we have mappings, parameters and arguments. And then we have this is a parameter. This is a parameter here. So you can decide to put in anything here, and that's an argument. So we have we have arrays, we have ordinary arrays, and those are fixed arrays, and then we have dynamic arrays where we can define a larger number of arrays. So these are these are the basics of Solidity. So we are going to write a code where we are going to apply payable. Oh yeah, so the basics of Solidity include payable functions as well. Remember, I told you about functions. Yeah, there are different types of functions. We have the payable functions. Even we have the payable functions, and we have even your where is it? So among the basics of Solidity, we have the functions as well. We have, for example, we have the constructor, we have the fallback, we have the receive. These are payable functions, so for the contracts, for let's say the more complex contracts that I wrote in my week 3 of blockchain development, that's the deposit contract, which involves application of these payable functions. So here you can see, okay, let me explain this contract containing payable function. So here we have a constructor, and we made it payable, fallback, all these they are payable here. So payable here is telling us that this function enables the contract to receive airtime. Here, this function, this is a view function, and this returns the balance of the owner of this contracts. And then the function here is a function that allows us to send ether out of this contract. So we are going to apply this deposit contract, which is here. So we were given our assignments. We are to write a contract. We were to write a contract that deposits funds into a contract, keeps track of funds transferred into the contract, and add a function to the balance of the address that has deposited into the contract. So in Solidity, before you write any contract, you have to specify this contract here. Contract, you give it a name, and then you open curly braces, and that is how the contract starts. So from here, we've been able to write the function to make the contract receive ether, which is actually here. And then we have another function here to show the balance of the contract. And then we have a function here that can show sender balance, external view, returns concerned integer, return msg.sender.balance. This helps us to get the balance of the person, or let's say the address that is sending ether into this contract. Then we can compile our contracts, like we mentioned earlier. You have to compile the contract. Remix helps us to do that. After this, for it to compile, that's compiled, and then come to the deployment area. So here we are going to be testing the functions that we have in our contract. For example, this is used to receive ether. So our balance is 0 ether. From here, this is the address that we used to initiate the whole contract. As you can see, it is no longer 100. It is no longer 100 because part of the ether here can be used to pay for initializing that contract, to pay for gas fees. So from here, we can send ether into our smart contract. So let's say 20 ether. 20 ether. We have to change this here to ether. Then we come down here to see our ether. So this contract has 20 ether. Show balance at 20 ether. This is showing 20 raised to the power of 18 because it is showing the balance in G-Wave. That is the lower denomination of ether. So here we can show the sender balance, how much does this sender have, and then see that the sender has 79,999 ether, which is yeah, this is actually approximately 78 ether, as you can see right here. This is the balance of the person or the address that sends ether into our contract. So that is it. With this, I believe I've been able to explain the basics of Solidity.
So guys, we've come to the end of this session. Thank you so much for watching. Thank you so much for listening. Next week we have more contents. We are going to write other smart contracts. We are going to compile. We are going to deploy other contracts. So see you next week, same time. Have a wonderful weekend.